should be, you gotta find the point that's somewhere along this line, it could be anywhere on this line that goes on infinitely, that's closest to there. What's your sense? Where would it be about?
Negative.
Like what area? Like up here somewhere, over there, where is it?
In the
Down.
center.
In there, very good. Everyone agree?
Mhm.
It's always good to get feel like it's gotta be in there, right? It'd be like almost going from here and straight there like in a
Perpendicular.
perpendicular line. That's what it would be. So our answer's somewhere around what? That. So we're gonna remember that, Amber. It just helps us, right? When we get an answer, if the answer is x equal to 6 or something, like, I did something wrong. Because I know the x value is gonna have to be what?
Perpendicular.
Negative, the y value will be positive, right?
Mhm.
We're looking for that point at one, this x, y coordinate that's sitting on there. I should label the origin. What's the origin as a x, y coordinate?
0, 0.
0, 0. Because we're gonna plug that in there. 0, 0, right? That'll make that formula a lot easier. I do wanna point out, those of you with expert geometry skills, you could work this problem another way. Because you see that little perpendicular line, yeah. All you in here, pre-calc skills, you know, like law of sines and the law of cosines, things of that sort, you might be able to go, oh, I got another way I could solve this. So that's the beauty of this, but we'll do it through calculus. We're gonna start with the distance formula. Okay, distance from the point to, what was it, the origin?
Mm-hmm.
Well, I love that. I don't even have to put my subscript 2's anymore. I should pretty that up. What would that look like? Sometimes you play around with it until you get it really nice. That's way better. But I still have the sad face. I still have the sad face because I need to get it all in terms of what? One variable. Any suggestions? And then you look around. You look at your work. You look at what you got.
2x minus 3 squared.
So what do you think? What can I put in place of y?
2x plus.
So you're saying take this equation right here and substitute it there. Correct?
Mm-hmm.
All right, let's see. We're gonna have to FOIL it though, huh? That's it? See, now I'm smiling. Look, we got this, the hardest part. Getting the formula set up, created for the problem. Last one was a box. This thing's a line. We use distance. We're gonna get everything in terms of one variable. At this moment, we're really golden. We're set. Even if I blank out of my calculus process, derivatives and stuff, I can support myself with a tool like a calculator. Maybe graph this. Graph this function, find where maxes, the maximum point is, right? If I blank, we're not gonna blank out, but you know what I mean?
Mhm.
It's at this point where you're like, okay, I got this thing rolling. But I will FOIL that. I'm
4x,
getting-
4x squared plus 12x plus 9.
So we just did a little FOIL. Right, I know, that's not 4x squared plus 9, is it? We gotta actually FOIL that thing, right, expand it. Any like terms?
Yeah, x squared. 5x squared plus 12x plus 9.
I've yet to do a D prime, look at all the work. Although some of you do like 2 steps at once, it's fool. 5x squared. You ready to differentiate?
Mm-hmm.
It's time. Don't set that to 0. Take the derivative, set it equal to 0. How do we do radicals, all this to the 1/2 power?
Yep.
And maybe I should write that first.
So,
Let's get everyone's rep. Here we go. It's gonna be a chain rule, isn't it?
mm-hmm. So
Alright, I got my dash. D prime. A 1/2,
half of then 5x squared plus 12x plus 9 root.
increase all this by 1.
Yep. Times 10x plus 12.
Negative 1/2, right everyone? It's up in the numerator though, I haven't moved it down yet. Some of you do that right away. Chain rule. Chain. What's what is the derivative of 5x squared plus 12x plus
10
9?
x plus 12.
It's funny because that little chain is what's gonna give us our answer. That's the funny part. You'll notice patterns with optimization. It's the chain that's really gonna solve this problem for us. So now, let me just write this a little better. I've got d prime equal to, okay, in the denominator I got a 2 down there. The radical return to the bottom, 5x squared plus 12x plus 9. And up in the numerator I got this 10x plus a what? Well, is that 12?
12,
And I'm setting all this equal to what?
0.
Now again, with distance, I do get to ignore this denominator. I don't have to worry about setting this denominator because you go why? Because that's the actual distance. And then we were not saying that the distance would be 0. So I'm not concerned with that at all.
Couldn't you just cancel out terms?
You know?
2?
You sure could. You sure could. Okay, but Belraj, I'm not even gonna be concerned with this thing right here, but I'm gonna take this numerator and set it equal to what?
0.
0. Unless you want to, did you hear him? He says you could have divided both of these by what, 2s?
Mhm.
But it doesn't matter because what's on the right side? 0. We'll get the same answer. So if anybody was in here going, why isn't he put the 2 with these? You could. You'll get the same result. But I want to tell you that that's really, that G prime is going to give us our answer. Setting that to 0. Looks like we're getting a negative answer here.
So that's the negative x coordinate, basically.
That's the x coordinate of that ordered pair. It's negative like we expected. And it's like, what, negative 1.2? If I wrote it as a decimal?
Yeah,
What's as a fraction? 6 what?
6/5.
Well, let me go back to the image. That looks about negative 1.2.
Yeah.
Looks like we did it right. Now, how do you get y?
You're plugging out.
Unless you want to put the fractional format when you could write it as a fraction. Negative 6/5. All right, I got to plug negative 6/5 or negative 1.2. Let me get the negative on there. Into
Original equation.
right there. All right. I think it'd be easier with the fractions. All right, what's that? All right, how do you add negative 12/5 to plus 3?
So
I have to multiply a what?
5.
5 over 5?
Mhm.
Right, Amber?
Mm-hmm.
Let's see what we get.
Did you just put in a decimal?
Oh, yeah, heck yeah. So it wasn't like even a run on, like a 1.3333 or anything, like it was a nice 1.2 negative, so feel free to do that. This would be 15 over 5, which gives me a positive 3/5. Amber, what's that as a decimal?
0.6.
If your answer is negative 1.2, 0.6.
Yeah.
The question, let me go back to it, make sure we answered the question. Find the point on the line y equals 2x plus 3 that is closest to the origin. That's the answer. There. Right there. Not trying to scale. Just me.
On the test, will you accept answers that are just in decimal form without being simplified?
Absolutely, except for one thing. What if your answer was this? And a student writes this. I'm taking off a point.
You have to put a
What are you gonna put
bar.
on top?
Bar.
Now it's fine. Right? Unless I said approximate the answer, then you'd be alright. Oh yeah, you can. That's no problem. I know what you're talking about though, there's ones where it said, unless it said find the exact value. So I know what she's asking about it when, we had an answer, was it yesterday? It was like 4 over the square root of 3? The points of inflection, do you remember? It was a 4, the top became neat. Perfect 4.
4 over root 3.
4 over root 3. Josephine, the only time you'd have to leave that is 4 over root 3 if the question said find the exact values of the points of inflection. Right? Cool.
Is it okay if we just do fractions? If we're not good with the decimal?
Heck yeah.
Oh.
Oh, that's awesome. Let me write that, negative what? 6/5?
And
The way to go. You're always safe with those. Always safe. All right. Doing a great job with that. Any other questions on optimization?
One more question.
You want one more?
Yeah.
Anything?
Yeah.
All right. I'm gonna try to scan through all the problems I got listed, one we haven't done yet. Will that work? Has anybody tried 23 yet? You tried it? Wanna play with it?
I started it.
Let's play with it. Let's play with 23. Listen to this. Try to make a sketch of this, ready? Find the dimensions of a rectangle of largest area that can be inscribed in a circle of radius r. Now, inscribed means what, inside?
Mm-hmm.
But they said rectangle, huh? Okay, rectangle inscribed in a circle radius r. Now radius is the distance from the center out to a what?
To the
Edge?
circumference.
So would that be r?
Mm-hmm.
And then this here would also be what?
Or,
R? Okay. And what are we trying to do? Let me go back to the question. Find the dimensions of the rectangle of largest area. Can we put that in our own words? We're trying to maximize the area of what? The circle or the rectangle?
Rectangle.
We're trying to maximize the area of the rectangle. We know it's in a circle, but we're trying to maximize the area of the rectangle. What's the area of a rectangle? Length times width. That's what we're trying to maximize.
Is this graph given?
What's that? The picture?
Yeah.
No, it wasn't. But I want to point out, so here's what they did. They just wrote a question. They go, find the dimensions of a rectangle of largest area that can be inscribed in the circle of radius r. So where I started was we start making a picture, right, Sarah? That's where we start, like our circle. Then I started shoving a rectangle inscribed in there of any size. I'm just like, okay, I'll draw a rectangle. The minute I hit a corner of the circle, I gotta stop. I came down and I make the thing. And then I realized, well, radius r, I know that's distance from center out to an edge. But rather than put my radius here, I thought it'd be nice to put the radius to go to what? To one of the corners? So what's this distance right here? 2r?
Yeah.
Alright. Now, we got this length right here to be 2r.
Is equal to D.
2r for that. But we need area of rectangle in terms of how many variables? Length times width, right? Where can we go from here?
you can, okay.
So-
Can you just like fold the rectangle and get the length, or the,
2r square equals to x square plus y square.
yeah.
Oh, so you're saying this is 2r, and you're saying this is what?
X,
That's what?
y.
So x squared plus y squared must equal what?
2r square.
Okay. Now what's 2r squared?
4r square. Hey, so far so good? What, can we get one variable out of that? Mhm.
And when area equals x times, what would y equal?
4r square minus x square.
4r squared minus what?
X square.
So first so good?
Mhm.
So what would this y alone be?
2, 1
I wish.
Square root of
It's gonna look ugly, isn't it?
Square root of 4 squared minus x squared.
Why did you just make that a 2? Oh, it's 'cause it's make, okay.
Cool. So it looks like in our answer, when we do all this math, we're just gonna have to leave our answers in terms of what variable? R. Right? We're just saying R is some constant. And we would change with what? Different rectangles, true?
Mhm.
We're gonna write the answer in terms of the radius. You know, circles change with different radii. We can write this answer in terms of radius, which would be kinda cool. So far so good. I'm smiling right now. Because we're gonna write this thing in terms of R. But how do I differentiate that? What rule?
Do you know?
Product rule. Right?
Override it though, right Amber? What's in front of that daggone radical? An x. Do you see it? Look, we got x times square root of this. Yeah, you got a chain rule on that part. Looks like product rule, right? As we go along, we're gonna have a chain rule. So like you're my m and you're my what? Alright, I'm gonna try it. M times m prime plus.
N times m prime.
3 of these will be easy. One's gonna be tough. Alright, what's that?
X.
N prime, I'll come back to you. What's that?
4r square minus x square root.
What's m prime?
Minus 2.
No. R is constant. So that should be